Hello friends, we are continuing with series of videos on cuda and HPC. So this time actually we are not going to use an HPC machine or a Jetson Nano machine to do the programming on cuda. This is going to be using a free Google Colab. Now as you can see on the screen, this is going to be a hello world example from a GPU that is going to be allotted to you freely from Google Colab. So what is a Google Colab? Most of you know this is a free hosted Jupyter notebook service that requires no setup to use and provides free access to computing resources including GPUs and TPUs. And TPUs are more used for AI related stuff which has full support to TensorFlow and also is a Google product. And Google Colab uses Python normally by default, but it is possible to code using C and C++ also. So now coming into cuda. Cuda is a parallel computing platform as we discussed earlier by NVIDIA. Now many of these content of this video is taken from tutorial point. Now you log into the Google Colab and you will see that actually you will be allotted a GPU that is the backend compute engine when we log in from your free Google account. Then you in this particular case it allots, see it has allotted 12.7 GB and GPU RAM of 15 GB. It's a lot of big resources have been allotted to you freely, and the disk information is also there. Now the file name, now the try.ipynb, that is the file name. And whenever you do this coding, since it's going to be C program, you have to write these lines cuda_code equal to the specific syntax, whatever is written has to be used. And also at the bottom of the program you have to use with open hello.cu in the write mode. That means you are creating a file called hello.cu which contains this program. And f.write cuda_code. This is what this many things you have to write as part of the cuda program when you are doing from Google Colab. So the code looks like that. The first line you can ignore, and this is like a standard C program like what we discussed in the previous videos. This is the main program which is executed in a CPU node, and this is what is executed in the GPU part. And here the kernel is launched with a function cuda_hello which is written here in the global. This part is going to be run on the GPU. So we are calling with a one block and 3 threads, and that means we are going to run this. We are going to call this function in from 3 different threads. It's going to be executed and it is going to print 3 times hello world. So this is how the diagrammatic explanation of this. This is a block with 3 cores, and each core 1, core 2, core 3 will execute the function hello world from GPU. See, now you can simply say exclamation nvcc -oop hello.cu to execute this program, and from the cell actually. Then you can run the profiling like earlier we did. We can profile the output program using this particular command too. So after profiling, we found now it is taking only 79 microseconds, almost 10 times it was taking in the Jetson Nano in the previous video. Now it's taking only 79 microseconds. So it is much faster than Jetson Nano which we discussed in the earlier video. So this is how the outputs look like. Hello world from GPU was printed and profile output 79.712 microsecond was seen. And now we are going into the practical demonstration of this. So as you can see, this is your Google Colab account, and you are getting into this system. So basically we are logging into the system right now. So already you are into that, and you are actually executing the program which we already create. You can always open a free account. This is my account. So you can see that untitled 1.ipynb is a file. Now when we run this, you will see that actually the program is opened. The program looks like that. Whatever we explained, actually hello.cu is here. You can see that you can even write like this, the percentage write file hello.cu instead of the earlier convention of syntax. Now we can profile it. You can run it using nvcc -oop like this, and you see after running we could see it took in this particular case 78 microsecond. This was for 1,1. That means the kernel was launched for one thread in one block. Now if we change this into 3, like we had done in Jetson also, in Jetson we could see hardly any much difference when we did 3. Let's see what is the difference it is going to be in this particular case when we run it from here. So now when we compile this program for 1,3, you can see that you are simply clicking on the cell exclamation nvcc -o. So here it took 79.3 microsecond. So that's all about this video. Thank you.